In the previous video, you saw a method for estimating the total amount of dust that will accumulate on the Mars rover's solar cells. This method, in general, is called a Riemann sum. Let's start by looking at another example. A scenario that you might be familiar with is accumulating distance when you're traveling. For example, let's say that the function r of t tells you the number of meters a moving car accumulates in each second, and you collect some data that shows the rate of accumulation at various points in time. Let's add some space to record the time intervals, and also some space to record the distances traveled. So if you look at the first interval from 0 to 2 seconds, that has a change in time of 2 seconds, as do the rest of the time intervals. To compute the distance traveled during that first interval, you could use either the rate at the beginning of the interval or at the end. For now, we'll use the value at the beginning of the interval. So you'd assume that you're accumulating distance at a constant rate of 1 meter per second, and you'd multiply delta t by the rate of accumulation for that interval, which would give you a distance of 2 meters. You could keep on doing this for each of the other intervals, and then add them up to get that you've accumulated a total of 44 meters. We also could have done these computations using the endpoints of each interval. You'd do the same thing as before, but, for example, in the first 2-second interval, you'd assume that the rate was 3 meters per second for the entire interval, so you'd get a distance of 6 meters for that interval. If you do this for all of the other intervals, you'd get a total distance of 54 meters. There are a couple of things to keep in mind here. First, we assumed that r of t was constant over each interval. So, both the 44 meters and the 54 meters are approximations of the actual distance we traveled. Second, you might be inclined to think that the 44 meters is an underestimate of the actual distance, and that 54 meters is an overestimate. You might be thinking this either because the 44 meters came from using the rate at the start of each interval, or because the 44 meters is the smaller of the two estimates. However, it isn't necessarily true that using the rate at the start of the interval will give you an underestimate of the distance traveled. For example, if you look at the estimate for the second interval, we assume that we are accumulating distance at a rate of 3 meters per second. However, we might only have been accumulating at a rate of 2 meters per second for most of the interval. So 6 meters is probably an overestimate of the distance that we traveled in that interval. Thus, the 44 meters might not be an underestimate, and 54 might not be an overestimate. Let's look at how this translates to more general mathematical notation. We had information about r of t, the number of meters we accumulated each second. Another way to think of this is as speed. Our goal was to find the total distance that we traveled. To do this, we looked at values for r of t. We assumed that r was constant over each time interval. Then, we multiplied the value of r by the change in time to get the distance traveled over that interval, and then we added up all of these distances, starting at 0 seconds up to 12 seconds, to get an estimate of the total distance traveled. We got 44 meters when we used the speed at the beginning of each time interval. In general, you use Riemann sums whenever you're trying to find the total amount of something that will accumulate. In the previous examples, we were accumulating dust and distance. To find the total amount of dust or distance, you start with a rate of accumulation. So here, r of x tells you how quickly something is accumulating at each value of x. Then, you need to assume that the rate of accumulation is constant over each interval that you're looking at. Then, you multiply the rate by the size of the interval, delta x, and finally, you add up all of these products, which we write using a symbol called sigma. This sum of products is called a Riemann sum.